Scientists have detected unusual seismic activity under the Antarctic ice sheet that may indicate a previously unknown magma chamber. They identified this potential new magma chamber by listening to recent volcanic eruptions that occurred beneath the thick ice covering Antarctic's Transantarctic mountains. In other words, there might be a volcano under the South Pole. But before you start making plans to visit the most southern volcano on Earth, keep in mind that it's still pretty far south. We're talking 98 degrees south latitude, which is more than 2,400 miles from the geographic South Pole. And since Antarctica is covered by an ice sheet up to 3 miles thick in some places, any eruption would still be pretty buried. But even though this potential volcano is still pretty well hidden, scientists have been able to study its rumblings thanks to seismic data collected by the International Array for the Research of Ice Sheet System in Antarctica, or ARISE. That's a mouthful. This international collaboration of researchers deployed 264 seismometers across Antarctica's Transantarctic mountains back in 2017. Their goal was to study how the ice sheet affects the movement of the continent's lithosphere, or the rigid outer part of the Earth. As part of this project, they left the sensors recording continuously, which just kept on recording even after the research team had packed up and gone home. And that's how they were able to pick up 3 volcanic eruptions that happened between June and August 2020. The earthquakes ranged in magnitude from 4.5 to 5.2 and were caused by an uptick in activity at Mount Marshall, a volcano that hasn't erupted in at least 1.3 million years. The thing is, based on the location of these earthquakes, the scientists think the magma that caused them might not have come from Mount Marshall itself, but rather from an unknown magma chamber that's buried beneath the ice sheet. There's a central magma chamber somewhere underneath here that we don't know about. It could be quite large, and that's what's driving the volcanism in this region, says Simon Seska, a geophysicist at the British Antarctic Survey and lead author of the study published in Nature on May. It's possible that the magma has been slowly moving toward the surface for a long time, and then something changed in the ice sheet above it, perhaps due to ice flow or the weight of a nearby glacier, allowing the magma to finally reach the surface and triggering these earthquakes. Or alternatively, these earthquakes could be completely unrelated to the magma chamber and instead represent just normal tectonic activity along pre-existing faults. The region where these earthquakes occurred is a convergent plate boundary, meaning 2 tectonic plates are colliding. The Pacific plate is moving east, and the smaller Antarctic plate is moving into it, like the smaller plate is sliding under the larger one. That process is actually what built the Transantarctic mountains up over the past 15 million years. So while there are plenty of faults in the area, there aren't any volcanoes, at least none that we knew about until now. In order to figure out what's really going on, the researchers want to collect more seismic data using a network of continuously recording instruments like the one used in this study. They also need to drill down through the ice sheet to see if there's any sign of recent volcanic activity. But drilling in Antarctica is no easy feat, and because of the harsh conditions, it can take months for the equipment to get back usable data. Still, scientists are excited to learn more about this mysterious rumbling. Even if it turns out that the earthquakes were caused by tectonic movement and not volcanic activity, that will be an important discovery in and of itself. By shedding light on the forces shaping the continent, we can better understand what might happen in the future. For example, knowing more about how the lithosphere moves could help us predict when the next big earthquake will hit the area. And although this particular region of Antarctica is very remote and the risk to humans is low, figuring out how earthquakes happen in different tectonic settings benefits our understanding of this natural disaster all over the world.